Welcome to Simple Life Fact. Discover the hidden truth behind every life. Right now, the sun is powered by nuclear physics. Every second, it releases more energy than humanity has used in all of history. And it has been doing that for billions of years. Now imagine this. What if the same science that powers the stars could power every home, every city, and every country on Earth? Could nuclear physics really power the world for generations? Let's break it down, simply. Everything around you is made of atoms. Inside every atom is a tiny center called the nucleus. And inside that nucleus is a huge amount of stored energy. Normally, that energy stays locked away. But when certain heavy atoms, like uranium, are split apart, they release heat, a lot of heat. This process is called nuclear fission, and that heat can be used to generate electricity. No burning coal, no giant flame, just energy from atoms. A nuclear power plant is actually very simple in Step 1, atoms split and create heat. Step 2, that heat boils water into steam. Step 3, the steam spins a turbine. Step 4, the turbine generates electricity. That's it. It's similar to how coal plants work, except instead of burning fuel, we're using atomic reactions. And here's something incredible. A tiny uranium fuel pellet can produce as much energy as a ton of coal. That's how powerful nuclear fuel is. One big question is, would we run out of nuclear fuel? The answer is more complicated than you might think. Uranium is already widely available, but today's reactors don't even use most of its potential energy. Advanced reactor designs can reuse fuel and extract much more energy from the same material. There's also another element called thorium, which is even more abundant than uranium. And then there's something even bigger, nuclear fusion. If fission splits atoms, fusion combines them. Fusion is the process that powers the sun. It takes tiny hydrogen atoms and fuses them together to release energy. The fuel for fusion can come from seawater. There is enough fusion fuel in Earth's oceans to power humanity for millions of years. Fusion produces very little long-term waste, and it has no risk of runaway chain reactions. The problem? Fusion is extremely hard to control. It requires temperatures hotter than the sun's core. But scientists are getting closer. If fusion becomes practical, it could change everything. Nuclear energy isn't perfect. There are concerns about radioactive waste, high construction costs, safety fears, long development timelines. Modern reactors are far safer than older designs, and new technology aims to reduce waste even further. But nuclear power requires careful management and strong regulation. It's powerful, and power must be handled responsibly. The same force that powers the stars exists inside every atom around you. Nuclear physics has the potential to provide clean, reliable energy for generations, possibly far longer than fossil fuels ever could. It's not magic, it's science, and the future of energy may depend on how wisely we use it. If you enjoy understanding how the universe really works, subscribe to Simple Life Fact. We make the complex simple.